introduce the engineer on the project. This was a grant, a 319 grant that Ohio EPA gave to the River Institute and Oxbow River and Stream Restoration Inc. designed and built the project. And I'm going to introduce Nancy Seger, who was the engineer on the project.
I work with Oxbow River and Stream Restoration. We are a design-build company that specializes in stream restoration. It's the only thing we do, predominantly in Ohio. Clover Groff is a ditch. Was ditched for agricultural purposes in the 1930s, 1940s. So when you ditch, you make the stream deeper, wider, straighter, and you take away all the trees. Those are the typical things for ditching, which basically means you take away all of the processes that a stream may have, with the exception of the capacity, the ability to carry water. So we've taken away everything natural from it, and now it's just a water course. So in Ohio, we look at the quality of our streams based on Ohio's water quality standards. Basically, if we have decent habitat, we'll have fish and bugs. We have fish and bugs, we have decent water. So the easiest of those things to measure and to watch is the habitat. It's a physical thing that's there all the time, whereas you don't have to know what kind of fish and what kind of bugs and those things. So we look at the habitat structure of the ditch. It's a 100-point system, the index that they use, 0 to 100. Ditches are in the 30s. Our goal is 60. 60 is a good number, and we can live with 60. So we're in the 30s, so if you kind of look at the range of that. So we've got a really poor system here that, because it's so flat, is never going to repair itself. It's protected, it's in a park, and there's going to be no more man-made damages to it, but it's never going to repair itself. So it just is. So in the early 2000s, Oxbow started working with the various agencies, kind of looking for places that were good for restoration projects. You know, where are some places where we can improve water quality, make a natural system, and have it protected. About 50% of the Clover Groff stream is held in public lands, either here, the park in Hilliard, or the park systems in the city of Columbus. So it made it a pretty good place to target restoration public funds. The Latham Park project is about 1,800 feet of ditch. In the construction world, that's a pretty manageable size project. It's a price that people can afford in a chunk. It's an amount of work that can be done in 3 to 4 months. So it's kind of a good size project. So we had this project out there, and we put it on EPA's mitigation website. So if somebody's doing some development damage somewhere and needs to restore a stream, Latham Park was a good setup for that. Unfortunately, it stayed there for 3 or 4 years with some interest, but nobody who wanted to go ahead and restore the stream. So we kind of struck out. So along comes River Institute, gets a grant. So now we have funds and we can restore the stream. So how do we do that? How do you take this ditch, make it a natural system that's going to have decent habitat for fish and bugs, and improve water quality? Kind of complicated, but maybe not so much. When you have a ditch, it's kind of like starting with a blank slate, and I can do anything as long as I get the water from A to B and make it nice in between. So a ditch is a perfect project as far as I'm concerned as the engineer. You know, our first step is to look at some interaction between the stream and a floodplain. So when it floods, we want the water to spread out. The more it spreads out, the less destructive it is. So less erosion, less damage. So we needed to construct a floodplain over here in Latham Park. So we did that. We took about 15,000 cubic yards of dirt out of this 120-foot swath. And luckily we had a pond that was just a pond. It really wasn't all that exciting. So we made an, we'll call it an island, but it's peninsula maybe, in the pond and a wetland bench, and kind of improved some of the diversity of the habitat in the pond with our dirt. So we didn't have to haul the dirt off anywhere. Then inside that 120-foot swath that you see is a curvy channel, a sinuous meandering channel that handles the flows from your pretty much everyday kind of rains. That's where all the action happens, is in this small little channel that you're going to see in the bottom. Because we were able to make it curvy, we can now maintain riffles and pools, and fish and bugs like pools, bugs like riffles. We can actually have spots in the stream where the water speeds up and aerates, as opposed to in the ditch it was kind of a stagnant laid there. So we create areas where we can process nutrients like nitrogen and phosphorus, take those out of the system. And while this is no longer predominantly agricultural watershed, we still use lawn fertilizers, and we still have golf courses, and we still have all of those same things that get in our water sources that you do in farmland as well. Along with that, we added substrate gravels into the stream. I think it's 700 tons. If you look at your handout that Dan gave you, it gives you kind of a list of the basic quantities that we put into this system. So we put gravels in there to create our riffles. We've planted, I have to look at this number, 4,000 plants that you'll see, shrubs and trees, all native to Ohio. The trees and shrubs will grow, provide the shade, cool the water off. They also provide the leaf litter and woody debris for the microorganisms that process the nutrients for their food source. So it's kind of a bunch of layers on top of each other. As far as a park goes, and you guys can judge that, but the straight ugly ditch that I would have been really afraid for my kids to step in is now a stream that kind of, it's got that natural look to it that flows through the park. My kids personally have played in this one since we've been done. They move the rocks around. So, we hopefully create an amenity for the park setting, as well as improve the water quality and get rid of, the eyesore and the negative source of water into the Big Darby Creek watershed. So that's kind of my overview. We're to the end of the grant. I had somebody ask me about monitoring. We do get permits for this kind of work. We get a floodplain permit because obviously floodwaters, because of a healthy safety side. We get a permit from the Army Corps of Engineers regarding actually being able to do work in a stream. That permit's going to require that we monitor our system for 5 years to make sure that we actually did what we said we were going to do and met our goal. I can tell you, so that 35, when we left the site, was a mid-50. Our goal was 60. And if you go out there today, you'll notice we don't have any grass yet. Our trees and shrubs, are just been planted. We just finished the project this fall. The trees and shrubs went in November. So, kind of give you an idea, by midsummer everything will be greened up. We're going to get really close to that 60 goal. And as each year goes by, we get a little bit closer as everything matures. So, Dan will be able to send in his grant reports and say, check all the boxes.
Well,
right?
That's the important part, is to check that box.
That's right.
But on the sheet are listed our other project partners, and I want to make sure and mention an important part of it is the easement along the stream channel that is held by Franklin County Soil and Water. And Emily Weber is here as the Assistant Director from Franklin Soil and Water. And it's very important to be able to have protection of the streamway and buffer either side of it with a conservation easement that's held in perpetuity. No, is that the right pronunciation?
Perpetuity.
Perpetuity, there you go. So that's an important aspect of the whole project, is having that, that buffer that will be held and protected. And so we're going to open it up before we're going to wait as long as we possibly can to see if we can get another degree or two out there. But if there are any questions, please fire away, because our experts are all assembled here. If anyone has a question or wants to comment. Otherwise, we will. Yes, sir.
I have two questions. Number one, it flooded in February pretty bad. Do you anticipate that that'll happen annually, and how much has that impacted what you just did?
Sure.
And then second question, does it flow east-west or west-east?
West-east.
And so will the construction going on all around it impact what you have done? Because there'll be more...
Sure. Well, we'll start with the flooding question. All of Latham Park is in a 100-year floodplain. It's all in a FEMA zone, which is probably why it's a park. Okay? So when we have extreme events like we did in February, snow, melt, and rain, the entire park's going to flood. And it's set up that way. That's what's supposed to happen. It happened before the project. It's going to happen after the project. The difference in, we've added a little bit of capacity to it because the dirt we took out, we put in the pond. You put the dirt under the water, it doesn't count. It's like it went away. Okay? So we got a little bit of extra capacity. Not that you'll see a difference for the huge storms. All right. The other difference that you'll notice, where maybe it stayed in that big trapezoidal ditch, now it's actually going to spread out over that 120 feet. It's not as deep. The water's not as deep. It has a visual that's flooding a lot more. But in reality, it's not more than it was before. It's just spread out. You actually want that. You want it to spread out. Clover Groff has a couple of other issues, and Hilliard and Franklin County are working on that. The culvert at Cosgray Road is at an oddball angle, and there's some elevation issues. They have a plan to put in a new conspan there when they widen the road, and it will make the alignment better, which will actually, our project is set up, it goes into the new culvert now, but it's set up to be adjusted to the new alignment. That should improve some of the problems there. Unfortunately, it's very flat, and the series of culverts have caused some issues with the stream itself outside of the project area. As far as other work that's going on in the watershed, when we size things for here, we considered that this watershed obviously is no longer agricultural, lots of residential, that all of this is zoned, that the natural system that we set up, because it's the smaller channel only deals with the smaller flows, and it provides relief when it floods. It's set up to be a self-maintaining system. So if those flows increase and that small channel needs to increase, we've given it space to get bigger or to adjust accordingly. So when you set up a system this way, you set it up for self-maintaining, and it will adjust over time. It's supposed to. Streams are dynamic systems. And basically what we do is set up a framework, then it can adjust accordingly within those limits.